Hello friends, today we are going to share you one concept, method and trick that you can use to solve any problem of one-way ANOVA with easiness. By the way, you can get PDF of this book by just doing comments below this video. So let's get started. As you know that in hypothesis testing, we test one mean or two means. But in a situation when we test mu1 is equal to mu2 is equal to mu3 is equal to up to so on, as you can say that when we test more than two means, we use ANOVA. Must remember, this is the definition of ANOVA. Now I'm going to move the example which you can use to solve any problem of one-way ANOVA. Here, example is given here, example number 20.1. This example is very important for you because by following the method, you can solve any problem of one-way ANOVA. I am 100% sure about that. Just follow the steps. So here, the first step is given here, H0, which is null hypothesis, H1 alternative hypothesis. Here you can write H0 mu1 is equal to mu2 is equal to mu3, very simple. And next you can write here H1 mu1 does not equal to mu2 does not equal to mu3. And the question we have to test there three population means. So I write here three population means. This is your first step. Second step, alpha is always equal to 0.05, and here already level of significance is given, which is 0.05. That's it. Third step, you have to remember this formula of test statistic, which comes from F distribution. F is equal to S square B over S square W. You have to remember this formula for one-way ANOVA always. You can also write here F is equal to S square C over S square E, because S square B is equal to S square C and S square W is equal to S square E. Next, must remember that in F distribution of one-way ANOVA, V1 is equal to K minus 1 and V2 is equal to N minus K degrees of freedom, as total degree of freedom is equal to within degree of freedom plus between degree of freedom. B shows here between and W shows here within and E shows here error. And must remember that columns C is equal to K, which is given here 1, 2, 3. And next R represent here rows. Rows are given here 1, 2, 3, 4. So here rows are is equal to 4 and next. And I'm going to move the next step. In the next step, n is given here, n is equal to 4 multiplied by 3, because rows are 4 and columns are given here 3. 4 multiplied by 3 will be 12. So n is equal to 12. Clear? And next, now I'm going to move the fourth step. Fourth step is given here about the calculations. This is very important step. In this, as you can write the question given, sample 1, 40, 50, 60, sample 2 and sample 3. That's it. Given here I represent here row and J represent here column. Must remember. First, in the first section, you have to take the squares of each value as xi1, x square i1, xi2, x square i2, xi3, x square i3. That's 40 square is 1600, 70 square 4900, 45 square 2025. As you can solve that here. And next you can write here total, and this value will be as it is, so you can write here dash. And next, this is the fixed method. Next, you can write here T dot J. T dot J you can calculate by adding the values of 40 plus 50 plus 60 plus 65, which is get 215. Next, sample 2 will 70 to 50 adding values will get 251, 45 to 42 adding values will get 185. Clear? And next, T dot dot. What is T dot dot? T dot dot is the sum of T dot J values, which are 215 plus 251 plus 185 will get 651. Must remember. And now in next section, you have to take the square of each value T square dot J. 215 square, 46225, 251 square, 63001, 185 square, 34225. Clear? And by adding this value, we'll get 143451. Clear? And next point we'll write here sum I x square ij, and next we will write here sum j x square ij. Clear? This is the fixed method. Next, sum I x square j, which you can calculate by adding the values of 1600, 2500, 3600, 4225 by column wise. Will get 11925 as it is, 15981 as it is, 8833. Clear? And next, sum j x square ij you can calculate by adding the values of row wise. 1600 plus 4900 plus 2025 will get 8525, and similarly you can follow the step, will get the value. And next, must remember that your question or practical will be true if the values of this and this value must be same. As this value, you can say that double sum x square ij, which is 36739, and this value is also is 36739. If both values are equal, it means your problem, your practical is correct. Otherwise, you have mistaken in the calculation. Clear? And next step, correction factor. Correction factor is always equal to t square dot dot over n. This is the formula. You have to remember this formula. T dot dot we have calculated here 651. Put the values whole square divided by n. N we have already calculated. Rows multiply columns, which is equal to 12 as given here. N is equal to 12. Clear? And next, in the next step here, total sum. Total SS. Must remember that total SS, which is sum of square. SS is equal to sum of square. Total sum of square is equal to within sum of square plus between sum of square. Must remember this formula. Total sum of square is always equal to double sum x square ij minus correction factor. I represent here row, j represent here column. This is also the formula. You have to remember that double sum x square ij we have already calculated, which is equal to 36739. Put the values. Correction factor we have already calculated 35316.75. By subtracting we'll get 1422.25. Clear? Next, between sum of square formula is also fixed. Sum j t square dot j over r minus correction factor. Must remember this formula. Very simple. Correction factor, total sum of square formula, and between sum of square formula you have to remember to solve any problem of one-way ANOVA. And next, sum j t square dot j. Sum j t square dot j is you have calculated values given here as t dot dot 651. T square dot j, by adding the values will get sum j t square dot j. So this value is given here sum j t square dot j, which is 143451. Put the values here divided by r. R rows are given here 4 minus fraction factor again 35316.75. By subtracting we'll get 546. Clear? And next, as you know that total sum of squares is equal to within sum of square plus between sum of square. We have already calculated total sum of square and between sum of square, but you have to calculate here within sum of square will be equal to total sum of square minus between sum of square. Clear? Total sum of square 1422.25 minus 546.00 by subtracting will get 876.25. Clear? And next step is very simple, the ANOVA table. Must remember the ANOVA table as it is: source of variation, between samples, within samples, total variation. DF shows a degree of freedom, sum of squares, mean square, and computed value of F. Clear? Between samples, here V1, degree of freedom V1 is equal to K minus 1. I have already told you about that. K minus 1, and K is given here 3, columns are 3. K is equal to C, which are columns, which is here 3. 1, 2, 3. Clear? So here V1 K minus 1, 3 minus 1, 3 minus 1 will get 2. Clear? Within samples, degree of freedom V2 is equal to N minus K. I have already told you about that. V2 is equal to N minus K. N is given here 12. Clear? 12. 12 minus, columns are given here 3. 12 minus 3. Very simple. 12 minus 3. 12 minus 3 will get here 9. So V2 is N minus K, which is 9. By adding the values, we'll get 11. Clear? Next, sum of square. This is SSB because B shows a between, W shows a within. SSB is given here 546.00, and SSW or SSE. You can also say that E or SSW or SSW. You can also say that because with SSW is always equal to SSE. I have already told you about that, which is SSW is given here. We have calculated here 876.25 mean square. Very simple. SSB divided by K minus 1, and we will get mean square, which is 546.00 divided by 2 will get 273.00. Clear? And next, SSE or SSW divided by N minus K will get 97.36. And last step will have computed value, which is, I have told you about that, F is equal to, this is the computed value, S square B over S square W, or F is equal to S square C over S square E. Very simple. This value is given here S square C. This value is S square B or S square C, S square B, or you can say that S square W or S square E. Clear? By 273.00 divided by 97.36 will get 2.80. As you know that in the F distribution critical region, if F calculated value is greater than or equal to F alpha V1 V2 will get reject as not, otherwise accept. Clear? F distribution, here I have calculated value of 4.26. How the calculated this value? Very simple. I have taken the table of F distribution. V1 is 2. Clear? And V2 we have calculated, which is 9. Clear? V1 is 2. V1 is 2 and given here V2 is 9. So 2, 9 between value we will get here 4.26. So I have written the value here 4.26 as so that as F alpha V1 V2 will be calculated 4.26 and F calculated value is 2.80. As you know that 2.80 is greater than 2.26. 4.26. As you know that 2.80 in fact is less than the 4.26. If a value is greater than from this, we will get reject H naught, but this case is accept H naught. Accept H naught because 2.80 is less than 4.26. Clear? I hope you have cleared the method of one-way ANOVA. By just following this method, I am 100% sure you can solve any problem of one-way ANOVA. Thanks for watching this video. Please subscribe this channel and like this video and share this video with your friends and classmates. Goodbye.